Hi, hey guys, welcome to LeetCode 42, Trapping Rainwater. In this challenge, we are given n non-negative integers representing an elevation map where the width of each bar is 1. Compute how much water it can trap after raining. So, you're already given an example which kind of gives you an idea of what you're supposed to be looking at, but I'll do a quick example through a very simple array, which is if we had an array of 102, right? In this case, it would look a little something like this, right? And in this case, we have one block here, one block, two block, and one empty block here. And here would be where the rainwater would get trapped. And this is what we're aiming to calculate, how much rainwater is trapped by this array, right? However, it's important to note that we can't, for example, look for just zeros, as someone might think to do or something along those lines. We can't look for just zeros because we could have an array that's presented to us as 2, 1, 2, which in this case would look something like this, right? So these representing our blocks. And here would be where the trapped rainwater would be kept. So in this case, then we can't be looking for 0 because we wouldn't turn out this result. So what we need to do for this kind of code, or for this kind of challenge rather, is we want to do a left to right sweep and then a right to left sweep. And so we'll have two arrays. We would have one left array, which will hold our maximum height, so the maximum height of our blocks here, from left to I, and then we want the same, but now for the right side, which would then store from right to I, right? And that way then we can then compare the heights and then use some maths to calculate the trapped water, right? Some very basic maths to calculate the trapped water. And then we can return our result. And so in terms of code, it's not particularly complex. I think it's just knowing exactly what to do and understanding this concept first of you need to be passing left and right. Then can you then work out how this works? So let's get into the code. Okay, so in terms of code, what we're looking to do first is our standard length. We just need to find the length of the array because it will come in handy in terms of having us type less. And then we want an if n is equal to or exactly equal to 0. Then we're going to return 0, right? This is just to catch out any cases that it's an array of 0, right? It's not entirely necessary, but it's a good like edge case. So now we need our arrays. So we're going to set a left array to equal new integer of length n. Yeah. And the same thing, right, new int n. Cool. And then we want another integer which will store, let's call it, trapped water, which will be set to 0. Oops. Right. So now we want to do our left to right sweep. So we're going to first set left to equal left 0 or left of index 0 to equal a height of index 0. And then we're going to do a traditional for loop, which will state that int I equals 1. We're going to start from 1 because we're comparing left to right. So we'll start from 1. I can be no greater than n, and we will increment. So now we want a for loop. Now we want to do the comparison, right, with a maths function, called max, which will compare our left I minus 1, and this is because of I minus 1 is because of the way that indexing works, to our height, which is whatever height we've managed to achieve so far. And we've set height to be 0 already because we're already at the first index. There is no height given. So now we want to do our right pass, which will state that n minus 1 will be the case, and then height, if we could spell height will be 0. Should also be n minus 1. And then we'll do our for loop, which will iterate backwards. So int I equals n minus 2, because again, the way indexing works, we want to start from the penultimate and not the last. And so n minus 2, I needs to be greater than, or equal to 0, and we're decrementing. And now we want to do our comparison again, which will be math.max right. And in this case, because we're going backwards, we're going to be I plus 1, and we will then do height I. Oops, that's an extra one. That's what I meant to do. Cool. So that's it for our left and right pass, right? So now we have a for loop, which is this iteration will then allow us to calculate the trapped amount of water, right? So in this case, we're going to do an int I equals 0. I is no greater than n. Oops. And we'll iterate. And then we want an int min height. So we want a min height integer, which will be the equivalent of another. So now we're looking for, instead of the maximum, we're not comparing for the maximum, we're comparing for the minimum. So math.min, and we're comparing left I to right I. And then we will then do the little bit of maths, which is pretty self-explanatory. For trapped water, we want to add to our integer the min height, take away the height. Oh, I really can't spell today. Yeah, I thought I had it right. Okay. Min height I, which then we can then return trapped water, and assuming everything is as it should be, we then get, I thought this was better memory, but we do get a decent runtime. Let me just re-send this in. How weird. This changes, but this is mainly what has been consistent in that it may not be the fastest, but I think the most important thing with something like this is understanding how this works first, and then if you want to try and redevelop it to make a faster, or to achieve a faster runtime, go ahead. But otherwise, just like in all software development, you need to understand the process, and then you can develop it to be a little bit faster. But anyway, I hope that helps. Please like, subscribe. And if you have any questions, or just want to say something, leave a comment. Thank you, and bye-bye.